Hello everyone, so today what we are going to show in this video is basically the different functions that this controller has. In the previous video we shown how it is, how it works, for how to connect it, for which use cases can be used, and in this video we are going to go through the options or work modes that this motor has. So basically it has in total 9 work modes, and we are gonna go through them, showing what they do and giving a bit more, let's say, insight regarding for which purposes it can be used. So we are going to start with the work mode 1. The work mode 1 can be selected if we press the encoder button constantly and we go to the function 1 and work mode 1. So we keep this and it will be set, okay? And the way this works basically is each time that we turn the encoder, as you can see, on each direction. So basically the motor is moving some steps. I can tell you that it is not only one step, because as you can see, it is moving a bit more, otherwise we will need around 200 in this case, since it is micro stepping 1600 steps. So as you can see, it is not moving the pure step, but it is moving accordingly to the encoder, right? So if we turn clockwise, it turns in this direction, as you can see on the magnet here, and if we turn counterclockwise, so it turns on the other direction. So this is the first mode, and there are no other options with this mode. Now we are going to check the mode number 2. So basically what we need to do to change the mode is keep the encoder pressed, and we are in function number 1, that it is the mode, and here one click, and let's go to 2 and keep pressed to save. So we are now in mode 2. The mode 2 basically it has one function, which is when we keep press any of the buttons, clockwise, counterclockwise, the motor will keep turning. When we release it, it will stop. As you can see, we press clockwise, so the motor is moving clockwise, and we can adjust the speed of the clockwise direction. Important, only clockwise direction speed. The other one, it will change when we press the counterclockwise, as you can see, and we can also modify it in runtime. And if we press now counterclockwise, so you see it turn in the other direction, and we can do the same and adjust the speed on the counterclockwise movement. So it's important to know, as you can see, that the speed is independently on RPMs for each movement. When we press, we set, let's say, the speed. Now we are going to check the mode number 3. So basically, as said, keep push, go to mode number 3, keep push to save. And in the number 3, what we have is constant RPM, as we saw in the first video. So I will say this will be the most used. We keep, or we press, and it will keep rotating clockwise. We press and we stop, and the other way the same, okay? So we need to press again to stop it. So we press, it moves, and we press to stop. We press, it moves, and we can also press run stop to stop. And the speed can be adjusted dynamically or when it is stopped. And one more thing, the speed is independent for each of the directions, okay? This is something that we always need to take in account. Okay, so now we are gonna see the mode number 4. This mode is a bit different from the previous one, so it needs a bit more parameters in order to work, and it is a bit more programming thing, but as I said, really easy. So let's go, let's select mode number 4, and we are gonna see how it works. So select it, and we are gonna see the parameters that we need to know. The parameter number 2, so this mode, what it will do is when we press clockwise, it will turn the number of steps selected on the parameter number 2. This means it will turn 1600 steps. This is one full turn, at least in my motor configuration. You have the information regarding how to configure the motor steps on the previous video. So basically, when I press the button clockwise, it will do, in this case, 1 turn. We can adjust it. We could put 2, 3, 4, 5, whatever we want. And it will do this a certain number of cycles, okay, that we can put it on the number 6. So basically, it will turn 3 times 1 turn, so 3 times 1600 steps. We could adjust this as well to repeat it. Let's say this is like a repetition, so we can adjust this to repeat it whatever, so 10 times, 11 times. And there is one more parameter for this, that it is the number 7, that it is the delay in seconds between cycles. This means that if we are going to turn 1600 pulses 3 times, between these 3 times it will be a delay of 1.5 seconds, okay, and this can be adjusted as well. So we can put here 2 seconds, for example, and we can do the same for the counterclockwise, but the settings, they are different, okay? So in this case, for the counterclockwise, it is the parameter number 4 for the number of steps instead the number 2. So in this case, we have 3200 steps, so this means 2 turns, and the delay is set in the parameter number 8. So if we put here, for example, 1 second, this means that it will do 2 turns, 1 second, 2 turns, 1 second, and 2 turns. So 3 cycles selected on number 6, the steps on number 4 with the delay that we have on number 8. We press counterclockwise. So we have, let's say, 2 options in order to work in if we press clockwise or counterclockwise. We can have different options. And important to know is that the delay between cycles is the same for both, okay? So we are gonna save and we are gonna test it. The speed can be adjusted, so it will be as always separate for clockwise, counterclockwise, and in this case here we are seeing the delay 2 seconds between cycles. So let's do it. 1, 2, you see that always the magnet is in the same position, and 3. And we are going to do the same with the counterclockwise. 2 turns, 2 turns, 1 second, and 2 turns, 3 cycles. And there is one parameter that we can also configure, which is the number 10, that it is what we are seeing on the display. So basically with 0 we are seeing the delay on the second line, and with 1 what we are seeing is the number of cycles. We are gonna see 3, okay? So as said, 1, 2 seconds, 1, 2 seconds, and 3 cycles. So as see, you can program some combinations in case that, for example, you have a slider and you want to move certain steps every, let's say, half a second or whatever. So I will say that for this kind of functions is useful. For continuing, we are seeing the mode number 5. So let's go to it. Basically, the number 5, it does the same like the number 4, but with a difference that it will return to the initial position. So let's remember, so we have configured 1 turn for the clockwise 3 times with a delay of 2 seconds, okay? So it will do 3 turns and it should return to the initial position. So let's see if really it does what we want. So let's do it. 1, 2, 3, and now it should return. 1, 2, 3. So as you can see, it works perfectly, and it will do the same on the other direction. 1, 2 turns, 2 turns, 3, and it will do 3 turns. 6, 1, 2, 3, 4, 5, 6. So as you can see, easy. Mode number 5, same as 4, but returning to the original position. Mode number 6. So basically the mode number 6 is a bit different from mode number 5. So we have configured on the clockwise that it turn 1 turn and wait 2 seconds, 3 cycles. The counterclockwise is 2 turns, 1 second, and the cycles it's the same, okay? But for the mode 6, so basically I have already configured it, as you can see, mode 6 on the parameter number 1. So what it will do is apply the number of steps that we selected for the clockwise, so it will turn, or it will spin 1 turn, so it will do like this, okay? Only 1. It will wait the delay for the clockwise, and it will turn counterclockwise, and it will wait the delay of counterclockwise. So let's take a look. So we press 1 turn, wait 2 seconds, and 2 turns, wait 1 second. And it will repeat this for the number of cycles 3 times, as you can see. So 2 turns the other direction, wait, and it is finished because it's the 3rd time. For what this will be useful, so if we want to go, for example, one direction, wait the other, one the other, like passes, let's say. So this is useful, and if we press the counterclockwise, it will do the same, but starting on the counterclockwise direction. So 2 turns, wait 1 turn, 2 turns, wait 1 second, 1 turn, now 2 seconds. So as said, for the clockwise is the clockwise steps and the delay for the clockwise, and the counterclockwise is the counterclockwise steps and the delay for the counterclockwise. So as said, this function is useful for going to one position and returning to other, and do this movement with the delay that we want. Mode 7. So this mode is a bit different. We only care about 2 parameters, the F7 and F8. So let's take a look to them. First, keep press, and we are going to change the mode to mode 7. Press run stop to go again to the upper level. And as said, 7 means 2 seconds, okay? So what we are going to do, or what this mode is going to do, is if we keep press clockwise, the motor will spin clockwise, okay? And will stop when we release the bottom, okay? When we release the bottom, it will wait 2 seconds and it will return to the original position. It will do the same for the counterclockwise, but it will wait this time that we set here on the number 8 till returning to the original position. So important to know. It will turn in the direction that we press till the moment that we release the bottom, and wait for the time for clockwise 7, counterclockwise 8, and it will return to the original position. So let's have a look. Let's press clockwise, wait 2 seconds, and it will return to the original position. So we can see it a bit better maybe with the magnet. So let's move this. It stops, and the same will do on the other direction. It will wait 1 second and it will return to the original position. So as said, for example, for a lathe, if we want to give passes and return, it will work, or for a milling machine, or for another kind of purposes that we want to return always to the original position, and when we press, keep turning. So only 2 to finish. Mode 8. In the mode 8, if we select it, that I already have it, okay, mode 8, there are 2 parameters or 3 that we need to care. Number of cycles, time for the clockwise. So basically what this is going to do is, if we press clockwise, it will turn 2 seconds clockwise, will stop for the number, or will stop 1 second and will continue, will do this for 3 times. So let's say we have this we are gonna change it to 3 seconds. Okay, so it will turn if we press clockwise for 3 seconds clockwise, and it will wait for 1 second, and this is going to be done 6 times. Okay, so let's say that we can apply, we are controlling by time, and we can apply a delay between cycles and number of cycles. So we have configured this. Let's see how it works. If we press this, 3 seconds, wait 1 second, 3 seconds, wait 1 second, and 3 seconds, and it will be done the number of cycles. In this case 3. And if we do the same but counterclockwise, it will take the 1 second as movement and the 3 seconds as wait. So 1 second, 3 seconds wait, and this is going to be repeat 3 times. This can be configurable. This can also work, for example, for a gimbal. So we can put, I want you to turn 1 minute, and the important thing is that, as I say, the speed is configurable. Okay, so again, we need to take a look that we set the speed in the mode that we want. Okay, because if the mode that we are is clockwise, the only speed that will change is clockwise. So as you can see, this is the way the motor is working for the mode number 8. And last mode, mode number 9. Okay, so let's put this number 9, and the parameters that are critical is F2, number of steps. F3 is not useful for this application. F6, that it is the number of cycles. F7, that it is the delay for the clockwise. F8, that it is the delay for the counterclockwise. And the 4, that it is the steps on the counterclockwise. Okay, so the way this is working, basically, let's save this, is it is a loop complete always. So what this is doing is turning clockwise 1 turn. Let me put this here. Let's wait. Okay, 1 turn, wait F2, and 2 turns, wait F8, and the same. And this is going to be done 3 times the number of cycles. So as I said, we press run stop, 1 turn, wait, and it will do 2 turns, wait 1 turn, wait 2 turns, and we can select the waiting corresponding with each direction. So basically, for F2 correspond F7, the delay, and for F4 steps correspond the F8, the delay. And this is going to be done 3 times. So basically, we can program a movement that it is automatically from one direction to the other, one direction to the other, one direction to the other. We don't need to do anything. The cycle, it will be completely done automatically. And for example, for a grinding machine that we want to go, come, it will be useful. And for other kind of machines that they need this oscillating movement. And now, last but not least, one important parameter that I wanted to check is the temperature. Why? Because at the end, the temperature will limit how long we can run the motor without having a thermal shutdown on the driver. And as you can see, the heatsink is not really big. Well, it's big enough for this purpose, but it has no fan, so it will have some limitations. And also, I would like to check the thermal dissipation on the PCB. So for this test, what I did basically is use a thermocouple. That this thermocouple is or was inserted between the heatsink and the component in a way that it was not creating an extra gap, but close enough to measure the temperature. And I was doing some temperatures that I will put you in the screen. So basically, if we take a look to the graph, okay, I did 2 tests, one at 2 amperes, one at 1 ampere. The maximum theoretically is 4, but I did not want to go that far because you are going to see in this graph that with 2 amperes I will say that the torque that we have is enough, and these are 2 amperes constant. So it's let's say rare situation for a long time. And as you can see, with 1 ampere, the temperature is quite stable. We could run almost all the time at this 1 ampere. And the maximum temperature that the case of the component reach is around, let's say, 65 degrees, which it is no problem. I tested for 500 seconds. And as you can see, with 2 amperes, we are already violating the component temperature. Let's say it's ambient, so it's on the case internally will be a bit higher. So I wanted to put this 85 as maximum on the case. And as you can see, we are violating this around 450 seconds, which is quite good, I will say, for this purpose. I don't expect that we are using this motor full torque at these long times. So I will say that it has good acceptable behavior. So with these values, you can already evaluate if will work for you or not. You can also find charts in the motor specs that relate torque with current, usually in the, let's say, good motors. So it would give you a good idea regarding if for the application that you are gonna use it will work or not. And I will say that for the moment, that's all regarding this controller. I hope you enjoyed the video. I hope it was useful for you in case you are going to use this controller. So please, if you find this interesting, you can click subscribe, enable the bell in order to receive the notifications, and also give it a like in a way that I will keep doing these small videos, or not so small, that showing you this kind of devices. I plan to have another video about how to connect the other version of this controller that has no driver included, and maybe another video for how to connect externally these signals in order to don't need these buttons here but having them outside. So I hope you see you soon.